Welcome to solving explicitly for the coefficients. So recall in the previous video, we found that the IVP x y double prime plus y prime minus y equals 0, with y of 1 equals 2 and y prime of 1 equals -1, had solution y equals the sum from n equals 0 to infinity of a sub n times x minus 1 to the n, where a0 is equal to 2, a1 equals -1, and a sub n plus 2 was defined by a sub n minus n plus 1 squared times a sub n plus 1, all divided by n plus 1 times n plus 2 for n greater than or equal to 0. So our job now is to find the first 7 coefficients explicitly. So again, we know that a0 is equal to 2. We know that a1 is equal to -1. So therefore a2, which is a sub 0 plus 2, should be a0 minus 0 plus 1 squared times a1 divided by 0 plus 1 times 0 plus 2. So we are looking at 2 minus 1 times -1. So 2 minus -1 divided by 1 times 2, or 2. And we get the A2 is 1.5, or 3/2. Then we can find A3. So A3 is A1 plus 2. So we're working with n equals 1. We're looking at A1 minus 1 plus 1 squared times A2 divided by 1 plus 1 times 1 plus 2. A1 is -1. Then we are subtracting from that 4 times 3/2 divided by, that's 2 times 3, or 6. So this is -1 minus 6 is -7/6. To find A4, right, this is a sub 2 plus 2. So we're looking at n equals 2. So this is a sub 2 minus 2 plus 1 squared times a sub 3 divided by 2 plus 1 times 2 plus 2. Plugging in, a sub 2 was 3/2. Then we are subtracting 9 times -7/6 divided by 3 times 4, or divided by 12. So this is 3/2 plus 21/2 divided by 12. Update my screen. 3/2 plus 21/2 is just 24/2, or 12. Divided by 12 is simply 1. I apologize. I think I need to use the other version of connecting. All right, hopefully this will work better. So again, 3/2 plus 21/2 is 24/2, or 12. Divided by 12, we're just looking at 1. So we have our A4. A5, we are looking at a sub 3 plus 2, working with n equals 3. This, we are therefore looking at a sub 3 minus 3 plus 1 squared times a sub 4 all over 3 plus 1 times 3 plus 2. And that becomes a sub 3 was -7/6 3 plus 1 is 4 squared is 16 times a sub 4, so times 1. Divided by 4 times 5, or divided by 20. Uh, 16 times 6 is 96, so we're looking at negative 103 over 120. And then finally, our a sub 6, this is a sub 4 plus 2, so we're looking at n equals 2 here. We have a sub 4 minus 4 plus 1 squared times a sub 5 all over 4 plus 1 times 4 plus 2. A sub 4 was 1 minus 25 times negative 103 over 120. All of this divided by 30. And I'm going to just leave it at that at this point. But as you can see, we can find the coefficients. Actually, we'll go ahead and finish. So we're looking at 1 plus we would have 24 in the denominator, 5 times 103. We're looking at 515 up top, all over 30. And this becomes 539 over 24 times 30, which should be 720. So we have 539 over 720. So we have that our y, we can write this as a0 was 2, a1 was negative 1. So we have 2 minus x minus 1 plus our a3 was negative 7.6. So I apologize, that should actually be a minus. Oh, I need a2. Sorry, a2 was 3/2. So we have plus 3/2. I apologize for the scrolling. Times x minus 1 squared. Then minus 7/6 times x minus 1 cubed. Plus 1 times x minus 1 to the 4th. So plus x minus 1 to the 4th. Then we have minus 103 over 120. Times x minus 1 to the 5th. Then we have plus 539 over 720 times x minus 1 to the 6th. And then we have a series of terms beyond that. So we have at least found an approximation. It's not the exact series at this point because we've only done the first 7 terms, but it could be a reasonable approximation for this series solution.